everyone, welcome to Made Academy's YouTube channel. My name is Veena Menon and today we'll be discussing Coulomb's law, one of the important topics from the chapter Electric Charges and Fields. We know that there are lots of charges present in the universe, and when these charges interact with each other, they experience a force. For example, let's consider a point charge Q1 and if we bring another point charge Q2 closer to Q1, we know that they will experience a force. So, by using Coulomb's law, we can actually calculate the force that is experienced between these two charges, point charges. So, let us assume that they are separated at a distance r. So, Coulomb's law states that the force that is experienced between these 2 point charges is directly proportional to the magnitude of the charges and inversely proportional to the square of the distance between them. That is, if you increase the magnitude, increase the number of charges, the force will also increase, and vice versa. If you increase the distance between them, the force will decrease, and vice versa. If you remove the proportionality sign, we need to keep a constant. So, K is the constant of proportionality, K into Q1 or Q1 Q2 by R square. Here in SI units, the value of K is 9 into 10 to the power 9 Newton meter square Coulomb inverse square. So, suppose if you keep the value of Q1 as 1 Coulomb, Q2 also as 1 Coulomb, and you keep the distance as 1 meter. So, now let us calculate what will be the force experienced. So, let us substitute these values in this formula. So, we will get F is equal to, we know the value of K, that is 9 into 10 to the power 9 into Q1 is 1 Coulomb, Q2 is also 1, R is also 1 square. So, one thing to note down is that the units are in SI units, so there is no need to convert them. So, this will come to be 9 into 10 to the power 9 Newton. Newton is the SI unit of force. So, even if you keep the charges at a distance of 1 meter, still the force will be equal to 10 to the power of 9. So, we can just imagine how powerful the force will be. Now, in this formula, K can also be written as 1 upon 4 pi epsilon naught. So, F will be 1 upon 4 pi epsilon naught Q1 Q2 by R square. So, this is the Coulomb's law. Here, epsilon naught is the permittivity of free space. And the value of epsilon naught is 8.85 into 10 to the power minus 12 Newton inverse meters square inverse Coulomb square. It will be just the reverse of this because it will only be the inverse of these units, because K is just inversely proportional to epsilon naught. Now what does permittivity of free space means? It means that how much force is allowed between those 2 point charges, or not only 2 point charges but between any amount of charges. So we are assuming that it's in free space, that is it is in vacuum. So we are assuming that the charges that we are talking about are kept in vacuum. So epsilon naught will be the force that is allowed between these 2 charges. If these charges are kept in some other medium such as glass or air, the interaction between them or the force experienced between them will be different. So this value will also change. As we know that force is a vector quantity, so we will write Coulomb's law in vector notation. So what is Coulomb's law? Coulomb's law states that the force is directly proportional to, this is the constant, it is directly proportional to the product of the magnitude of charges and inversely proportional to the square of the distance between them. So let's look at this diagram. There are 2 point charges q1 and q2, and the position vector of q1 from the origin is r1 and the position vector of charge q2 from the origin is r2. So they are also separated at a distance of r. Since both are vector quantities, both these vectors are going away from each other. So that means we need to subtract these vectors. So the vector will be in this direction, that is r21. So r21 can be written as r2 minus r1, right? So these charges are experiencing a force. So let's look at the case q1. Charge q1 is experiencing a force due to q2. So the force will be in this direction, right? Because q2 is here, so q2 will be affecting in this direction, right? So this is named as F12. Why 12? F12 indicates force on charge q1 due to charge q2. Similarly, q2 is also experiencing a force due to q1, which will be in this direction. So this will be F21. Why? Because F21 indicates charge on q2, force due to force on q2 due to q1. Okay, so these are the directions of the force. Now we need to write for each of these forces, we need to write the Coulomb's law in this direction. So for that the radial vector will be in different for both. So we will find out that for F21, let's consider for F21. For F21, for charge q2, the force is F21. So for F21, what will be R21? We know that R21 is R2 minus R1. We need a unit vector also, because we are writing Coulomb's law in vector notation. So unit vector will is necessary so that it specifies, because it helps us to identify in which direction the force is applied. So we need a unit vector. So what is the formula for unit vector? For any vector, if you need to find out the unit vector, formula is the vector itself upon the magnitude of the vector, right? So how will we write the unit vector for this? R21 cap indicates the unit vector. R21 is equals to R21, this is the vector, upon R21, this is the magnitude of the vector. Now we'll substitute, we'll put it in this. So it will be F21 is equals to 1 by 4 pi epsilon naught. Q1, Q2 will remain same, only the distance will change, right? So it will be R21 into the unit vector R21 cap square. So this is for F21. Similarly, we can write for F12. It's the same, only the numbers will interchange. So while interchanging the numbers, 1, 2, R12 is R1 minus R2. Can we write this in form of this? Yes, we can write. If you just take out the negative sign common, so it will be R2 minus R1, correct? What is R2 minus R1? This is equation 1. So from equation 1 we know that R2 minus R1 is minus of R21. So we can write F12 as 1 upon 4 pi epsilon naught Q1 Q2 by R12 square into R12 unit vector. It will be similar to this. R12 will be the vector upon magnitude. So we know that there are two kinds of charges. There are two kinds of charges. One is like charges and another one is unlike charges. So let's consider the case that Q1 and Q2 are like charges. So for like charges, what will happen? If they both are like charges, there will be repulsion, right? For repulsion, that means both of them will be going in this direction. So correct. So this formula F21 is for like charges. This indicates the direction of the force for like charges, and for unlike charges, Q1 and Q2 are unlike charges, they attract. So it will be in this direction, that is in R12 direction, negative of R21, right? So this is for unlike charges. Attraction, and this is repulsion. So if we look at equation 3 and 4, we can actually write both in terms of each other. Like if we substitute R12 as minus of R21, so this will be equal to this, right? So we can write this as F12 is equal to minus of F21, right? So this indicates that the forces are equal in nature but only opposite in direction. So we can say that Coulomb's law agrees to Newton's third law also, because in Newton's third law we say that the forces are equal and in magnitude but opposite in direction. So we say that Coulomb's law agrees to Newton's third law. So that's the end of the video. For more such educational videos, please subscribe to Maid Academy YouTube channel. Thank you.